Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I am Chigoloni and welcome to the science class for year 5. So, how are you children? Like our Minister of Health mentioned, please stay at home to stop the spread of COVID-19 disease. Now, to help you with updated with the lesson video that I posted in YouTube, you can always subscribe to my channel and please like the videos if you like it. And I also posted the links of Google Form in the description below the video that I posted, and also links for your notes. Notes are from these slides. You can always print it out and keep it at home. So shall we start with our lesson? We always start our lesson with dua. Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Rabbi zidni ilma warzuqni fahma wa sallallahu ala sayyidina Muhammad wa ala alihi wa sahbihi wa sallam walhamdulillahi rabbil alamin. So we shall continue. Are you ready? Our objective today is I will conduct experiments to make a magnet, and we shall identify ways we use magnets in our daily life. Now, what shall we do in this video? One is to recap previous lesson. Second is to conduct experiments on how to make magnet. Third is talk shortly about the experiments and talk about ways we use magnets every day. And after that, you can do your online exercises that I have provided. Okay, we shall recap previous lesson, that is one types of magnets, second properties of magnets. Now there are 6 types of magnets as you can see here, that is bar magnets, rod magnets, U-shaped magnets, horseshoe magnets, ring magnets, and button magnets. Now properties of magnets. Number 1, poles of magnets. All magnets have 2 poles, that is north pole or N pole and south pole or S pole. So this is known as north pole or N pole. And here the blue one is known as south pole or S pole. You must remember that. N for north, S for south. Now, second properties of magnets is attraction. Unlike poles attract, so N against S will pull each other closer. They attract to each other. N will attract S, S will attract to N. They will come close, pull each other closer, and this is called unlike poles. Unlike in the sama N, sama S attract. The third property is repulsion. Like poles repel. So here you can see the magnet N with N. Here S with S. Like poles push each other away. N sama N, N with N will push each other away. It's the same with this. It will push each other away. Menolak here. Dia akan tolak N sama N. S with S will push S away. The fourth properties of magnet, resting in north-south direction. If we hang a magnet like this or floats a magnet like this, when the magnet is in resting position, will points towards north-south direction. N yang merah, letter N will point to the north and S will point to the south, like a compass that I have shown last week. So we shall do experiment. Experiment 1, how to make a magnet. So there are 2 methods on how to make a magnet. The first one is by stroking method. What do we need? We need a permanent magnet, we need iron nail, or in this video, in the video later, I'll show you I'm using paper clips, and thirdly, paper clips to test our magnet. But then in this video, I show you using stapler bullets. So what do we do? Choose one pole of a magnet. You can choose N or S. Use circular motion like this one to stroke the iron nail using a permanent magnet for at least 25 times. So in this case, I'm using a paper clip here, paper clip, and Cikgu will stroke. This is called stroking for 25 times. After that, we can test our magnet. Now let's take a look at the video that I've mentioned just now. Okay, now the first experiment on how to make a magnet. Now here I have provided with 2 paper clips and some staplers for testing. Now the paper clip is non-magnetic. See, it doesn't stick to anything. So we shall try to make this into a magnet by stroking. So we straighten the paper clip. If we can see here, straighten the paper clip. Okay, I'll put this to the side, and this is the paper clip, and I have a magnet. So we choose one pole. We can choose either this or this pole, and using a stroking method, put it here, stroke, put it here, stroke, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21, 22, 23, 24, 25. Only 25 times. Now let's test whether this becomes a magnet. Yes, just one stapler. Yes, it becomes a temporary magnet. Okay, from the video that I've shown just now, I only managed to attract one stapler bullet. So the question is, did the experiment works? Yes, the experiment did works, even though it can only attract one stapler bullet. So another question is, how can we make our temporary magnet stronger? There are 2 ways that I know how to make a temporary magnet stronger. One is to use a very strong magnet, not the magnet that I use, maybe another one, a stronger one. The second way to make a temporary magnet stronger by stroking is stroking more times, more than 25 times, maybe 50 times or 100 times. The more you stroke, the stronger your magnet will be. So experiment number 2, how to make a magnet is by using electricity. If you can see here, making a magnet by electrical method. So how do we do it? What do we need? An iron nail, electrical wire or copper wire. Here is copper wire. and battery or dry cell. So how do we do it? Coil the copper wire around the iron nail as much as possible. Connect the wire with a battery or dry cell, and the nail will become a temporary magnet, electrical method, or we can also call it became an electromagnet. Then we can test our electrical magnet. Watch a video on how I made the experiment. Okay, for the second experiment, we have a nail and wire, copper wire, and a battery dry cell. So what we need to do is we need to roll this wire into on the nail. Start here and we roll it as much as possible. We can roll it this way also. So now it's done. So if you have a problem with this sticking out, get a tape and tap it. Okay, then we hold the wire, copper wire, to the battery, hold it, and what happened is the nail will become a magnet like that. So does the experiment works? Yes, it works. So did the experiment works? Yes, it works very well. But can you do it better? Yes, we can do it better. How? There are two ways on how to make an electromagnet better. One is by using a stronger battery or dry cell, and second way is by coiling more wires onto the nail. With these two ways you can make a stronger electromagnet. So next is, how do we use the magnets every day? What are the uses of the magnets? Number one, magnets can hold things together. Like here, we have this at home. It's fridge magnets. So fridge magnets is used to stick, we can stick papers actually on the fridge, or just to put decoration like this on the fridge. Another example would be a chessboard. Under here, under the chess toy here, they have small magnets, and these small magnets will help to stick it on the metal chessboard. And the third example is magnets on bags, like your mother's bags or wallets, or maybe your bags, school bags maybe. And number two, magnets are used in electric motors and speakers. If you see here, motors inside it, you have two magnets like this, and this will help with electricity, help the motor to run. You can find this motor in any kinds of motor, maybe in a car or in a toy car like remote control car. You will find motors, and inside every motor you will find magnets, and also in speakers like this one. Here is the magnets behind this. It's a ring magnet, and it is used in speakers. Next, third, magnets are also used in toys like this one, or like I said, like remote control cars. There's a motor and there's a magnet. Or here is the same. The magnets is at the corners, if I'm not mistaken, for this toy. I never played this toy. You might be, you have played maybe, but not me. But this is one of the uses of magnets. The third one, what, this is third, and this is the second, third, and fourth. Magnets are used in compasses. Compasses that I've shown last week. I've shown compasses, and the middle of the compass is made of magnets. It's a thin magnet, and this magnet floats like this one. It floats in the middle of the object of the compass. When at rest, the compass will point to north-south direction. We can use paper maps to help to show the way, like this one. In a paper map, usually they always point, there's a symbol pointing north, so you turn the map around until it can shows you north with north, like this one. If the compass shows north, so turn the paper map until it shows at the same direction as the compass, and it will help you to show where are you or which way should you go. It's the same like in handphone. In phones, we have small symbol here saying north, more or less like a compass. If I'm not mistaken, we have magnets in our phone, but that is yet I'm not sure. I'm not sure about that, but we can check it next time. So how do you use magnets? Nowadays, like I said before, we use paper maps like this one, but now we're using GPS, what we call GPS, or global positioning system, to know where we are. GPS uses many satellites like here in this picture, and there's a data information from your phone will be sent to the internet, the satellites, and they will send back to control, and the control will send data back to your phone to show you where you are. More or less, this is how a Garmin GPS, your phone GPS works. Number 4. Number 5, I think. Number 5, magnets can also be used to store information. Here, this picture shows a credit card or a card that your parents have. And the black strip is a magnetic strip, and it stores information. Information about how, about what? Maybe the name or numbers. I'm not sure what information there, but then there are information stored in the magnetic strip. And also, if you ever went to a hotel, nowadays they gave you this type of key card, and this black strip is magnetic. They have information inside, maybe the room number or maybe the code for the door lock. I'm not sure, but then information are stored here in this strip, magnetic strip. And in our computers, we do have magnets here to help us store information. Number 5.
Its way along a 12-mile
Number 6
test track
actually.
in Emsland, Germany. Here and in Japan, Maglev engineers are developing frictionless rail systems that propel trains at speeds up to 275 miles per hour. Wondering how you levitate one of these 60-ton rail cars? The bottom section of the train wraps around a T-shaped track called the guideway. A set of electromagnets lines both sides of the train's undercarriage. An electromagnetic field generated in the guideway attracts the magnets, lifting the train less than half an inch above the track. A second set of magnets lining the train's sides exerts a lateral force, keeping the vehicle properly aligned. If you're looking for the motor that propels the maglev forward, don't bother looking anywhere on the train. It's laid out flat along the guideway. A system of magnets, like that used on Magic Mountain's Superman roller coaster.
This is, for example, another application of the linear synchronous motor. If you synchronize the changing of the poles with the motion of the train, you can keep the forces going.
Train engineers aren't the only ones getting a lift out of magnetic levitation. Scientists at NASA are exploring how magnets can give the spacecraft of tomorrow a boost into orbit.
One of the
Okay, now from there, just now we have watched a maglev train or magnetic levitation train. Levitation means to float, a magnetic floating train, or short form maglev train, uses magnets to raise the train above the tracks. Now, in a maglev train, it doesn't use tires. It uses magnets only. It also used to move and stop the train. They said that using a maglev train, it can go faster, like 600 km per hour. China now, from what I read, they are planning to use maglev train to go from China to Europe in a few hours. I think 12 hours. No, not 12 hours. I'm not sure, but lesser than an aeroplane. So it is very fast. So what type of magnets used in maglev train? From the video that you have, if you watch and listen properly just now, it uses electromagnets. What other daily object uses magnets? There are many objects that we use magnets every day. Example would be a microphone. Maybe not every day, but you do know microphone. It uses magnet. And your phone might have a magnet. Or the cover of your father's phone. Sometimes your dad have phones that flip, that covers. It uses magnets. Okay, worksheet are provided in the Google form. I've said just now. You can find the link in the description below, and I also prepare lesson notes, and I will prepare the extra worksheet for you to do it in extra time in a few days. Okay, let's recap lesson. There are two ways to make a magnet: stroking method and electrical method. Lesson recap 2, there are many ways we use magnets. 1, to hold things together, example handbags. 2, use in electrical motors and loudspeakers. 3, use to make some toys. 4, use in a compass for direction. 5, use to store informations, example in bank cards. 6, use in trains, example maglev trains. Okay, thank you for watching the video week 30 from the science class this week. Do not forget to like and subscribe, and we will see you next week again for another lesson in the science class. Assalamualaikum warahmatullahi wabarakatuh.